Hi students. So let's start in this module with the calculation of oxidation number. That is, what charge an atom will carry when it is in its complex form or whenever it's in its compound form. So the very first oxidation number can be calculated by two methods. First by algebraic method and second method is structural method. Now when we say algebraic method is nothing but the rules which we studied in our previous modules and structural method which we'll be covering in our next modules, right? So first example we'll take is by using algebraic method is K-4. You can see here the underlying element is Mn, that is we have to calculate oxidation number of manganese in K-4 molecule. So let's just, with the help of the rules, we can say the oxidation number of potassium is +1 as it belongs to group 1 element. The oxidation number of oxygen is -2 as in its oxide form. And let the oxidation number of manganese be X. So if we calculate here, potassium is +1, manganese we take it as X as we don't know the oxidation number, and oxygen is -2. Since there are 4 oxygen atoms, we multiply -2 with 4. And the total sum of oxidation number, we take it as 0. Students, you do remember the rule number 7, where we say if the molecule is neutral, we take the oxidation number as 0. So, by simple mathematics, if we see here, the value of X comes out to be nothing but +7. Yes, so manganese have lost here 7 electrons. So the oxidation number of manganese is +7. Moving to our next example, that is Cr2O7-2, and here the underlying element is chromium. So let the oxidation number of chromium be X, and we know the oxidation number of oxygen is -2. So if we calculate, since there are 2 chromium atoms, we take here as 2X. Oxidation number of oxygen is -2, and since there are 7 oxygen atoms, we take 7 into -2. And we equalize this, that is the total will be equal to -2, because on the molecule if we see, it is not a neutral molecule, it is an anionic molecule where the charge on the molecule is -2. So the sum of all oxidation number we take equal to as -2. Right. So if we calculate here, the value of X comes out to be nothing but 6. So here the oxidation number of chromium is +6. That is, chromium has lost 6 electrons. And the maximum capacity of chromium is losing electron is 6. Moving to a third example, that is H5P3O10. And the underlying element here is phosphorus. So student, what is the oxidation number of hydrogen? Yes, it is +1. For oxygen, it is -2. And let the oxidation number of phosphorus be X. So if we calculate, we will take 5 of hydrogen, that is 5 into +1, plus 3 of phosphorus, that is 3X, and plus 10 oxygen, so -2 into 10. And we'll equalize, that is total oxidation number will be 0 as this is a neutral molecule. So if we calculate the simple calculations here, and the X value comes out to be +5. That is, phosphorus has lost 5 electrons, and hence in this molecule the oxidation number of phosphorus is +5. Moving to our next molecule, that is K3FeCN6. Now this is a coordinated complex, that is, it's a complex molecule here. How do we calculate for this? If you see here, the simple thing here is potassium oxidation number, we know that is +1. For iron, we don't know, so we take it as X. And for cyanide, students, do you remember we had done for certain complex molecules also? Yes, for cyanide, if you see the highlighted here, it is -1. And hence, we can calculate for cyanide as -1. So by taking these values, we will write it as 3 times of potassium plus X times of iron plus how many cyanide we have? We have 6 cyanide. So we will multiply 6 with -1 will be equalized to 0 as there is no charge present outside the molecule. That is a neutral molecule, right? So here the value of X comes out to be nothing but +3. That is, in this molecule, iron has lost 3 electrons, and hence the oxidation number of iron, that is Fe, in this molecule is +3. Our next complex is nothing but ZnNH4PO4. Now if you see here, we have 2 highlighted portions, that is nitrogen and phosphorus. How can we do for 2 molecules, 2 atoms in the same molecule? Students, zinc valence is fixed. As we know, the valency of zinc is +2 for all the complexes. It cannot exceed more than that. Neither it can be +1. It's always +2. So we know for zinc. Can you see your NH4? Isn't it a cationic complex which we have studied, right? And phosphate also. So if you see your NH4 is nothing but +1 and phosphate is nothing but -3. So we can apply the same thing here, putting NH4 as +1 and phosphate as a whole as -3. So now since we know NH4 is equal to +1 and out of NH4 we know hydrogen, right? Hydrogen is how much? +1. So taking value of nitrogen as X, hydrogen will be 4, will be equalized to +1 as NH4 as a whole will be +1, right? So we get the value of X as -3, that is nitrogen oxidation state here is -3, it has accepted 3 electrons. Moving to phosphorus, if we see PO4 is equal to -3 and oxygen we all know is -2. So taking P as X, multiplying oxygen as -2 into 4 will be equal to -3. So we get the value as +5. So here we can calculate oxidation number of more than one atom in the same molecule. I hope now calculating oxidation state is very much simple. So in our further modules, we will see the structural method to calculate oxidation number. Till then, goodbye and thank you.